Well, welcome back, and we've got an exciting topic tonight on the unit circle. So when we talk about unit represents a length of 1. Okay? And whether that's 1 inch, 1 foot, we're just saying a unit represents a length of 1. So the equation of the unit circle, well, if your radius is 1, you're 1 away, and we're centered at the origin, we would just say that's x squared plus y squared equals 1. Now hopefully we're familiar with the equation of the circle. Notice we're not adding or subtracting, so we know we're centered at the origin. And we have an x squared and a y squared. And again, this is our radius squared. So we're going to draw many of these circles out tonight, so just get your, draw the best circle that you can here. So our unit circle, like we said, is centered at the origin, so I'm going to put my axes in my picture here as best I can. And we're saying again by unit that this distance, its radius, so let's get it drawn in, this radius is 1 away. Basically every radii that I draw in is 1 away. Whether my radius went to the left or let's say it goes straight up, that's 1 away, 1 away, 1 away. Hence the unit circle means we have a radius of 1. Everybody on that circle is a length of 1 distance away. So let's go ahead and label a few things. Let's put our degrees on here. We know this is 0 degrees, 90 degrees, 180 degrees, 270, and then of course it wraps around back to 360. Now we also know 4 points on this circle. So think about this. If we are 1 away, you actually know the coordinates of this point. The coordinates here would be over 1 and up 0. So I would say that would be the point 1, 0. Think about the coordinates at 90 degrees. I move left or right 0 and I go up 1. So the coordinates at this point would be 0, 1. Can you fill in the other 2 points at 180 and 270? Take a moment, try it for yourself, and see if you agree with me. Go ahead. Do you agree with mine? I would say at 180 I would go left 1 and up 0, so -1, 0. And at 270 I would move left or right 0 and down 1. So not only do we know the degrees, we also know the coordinates at each of these now. Alright, so I want you to start fresh. We're going to draw a new unit circle. There's lots of little things we're going to pick up today. So the first thing I want you to do is we're going to label our initial side and our terminal side. So remember, an angle is made out of 2 lines, so I'm always going to start at the origin where my vertex is. And let's get this on here, the nice ray, and we will call this the initial ray, or initial side. And then wherever I draw my second angle, or my second line creates the next theta here. So there's my angle. We go counterclockwise. And we said, do you remember, this is called the terminal side. Okay, so you have your initial side and your terminal side, which make up an angle. Now basically, wherever that terminal side ends, I want you to put a big point, and we're just going to call it point P, and that point is going to be x, y. Okay, now, we don't know exactly the value of that point P like we did here. We knew this point, we said was 1, 0, because it was a unit circle. Remember, unit means you went out 1. And I knew this point up here was 0, 1, but I don't know the coordinates exactly of this point. I can tell you I know between what 2 numbers they are. For example, if this is a unit circle and this is 1 away, I know this x value is definitely less than 1. And again, if this is a unit circle and this y value is 1 and this y value is under it, I know this y value is definitely less than 1. So I know, like I said, the x and y value fall between 0 and 1, but I don't know exactly what it is yet. Okay, so like I said, we're going to get another fresh sketch of our unit circle. All right. I want you to draw in. We're going to put our new radius out to this point, and we're going to call it P. And I'm going to drop this line straight down, and I'm going to make a right triangle. Okay, so where's the right angle? Hopefully right here where it drops straight down. This angle that we made to the vertex is called theta. That's our angle in our triangle. Now, this of course is my hypotenuse. This is my, here's theta. Adjacent means next to, so this is my adjacent side, and opposite means the one across from. And most of us are pretty good at that. Okay, now we're going to set up a trig ratio to talk about this angle. So let's say the sine of theta, and if we think back to SOHCAHTOA, the sine of theta is opposite over hypotenuse. So let's go ahead and write this out. Now, this is only special because it's the unit circle. Look at my opposite side and my hypotenuse. Okay, since this is the unit circle, you do know the length of the hypotenuse. Remember, unit represents the number 1. So anytime I draw in a radius, I know that it is 1 away. So I'm going to put on my circle that h is equal to 1 because that distance is the unit circle and it's a length of 1 away. So I can say my sine is actually the opposite side over 1. Therefore, the sine is literally just equal to the opposite side. Okay, let me say that one more time. I drew in my radius and I dropped it straight down, so I made my right triangle. I said I know the length of the hypotenuse because this is called the unit circle. This distance is 1 away. So my sine is opposite over hypotenuse, which is what we wrote down, and we knew the length the hypotenuse was, that's 1, so it's really just sine is equal to opposite. So in our picture here, let's go ahead and say the opposite side is equal to sine theta. Okay, now let's do the same thing with cosine. Cosine theta equals, back to SOHCAHTOA, that's adjacent over hypotenuse. Okay, so now if I look at my picture, the adjacent side is right here over my hypotenuse, which has a length of 1. So I can say cosine is adjacent over 1, which is really just the adjacent side. So the cosine right here is equal to just the adjacent side. So A equals cosine theta. Okay, now that's huge. We're getting something really big out of this, guys. Because the x distance is cosine and the y distance is sine, this point P, x comma y, is really no longer x comma y in trigonometry. We just said the x value is equal to cosine and the y value is equal to sine. So in trigonometry, every point xy is now going to be called cosine theta, sine theta. Okay, and let's get this boxed in. This is a huge deal. Every point on the unit circle, remember this only works if it's on the unit circle, every point xy is now called cosine theta, sine theta. And that reason is right here. Okay, because the opposite over the sine, or the hypotenuse of 1 is just equal to sine, and the adjacent over hypotenuse 1 is equal to cosine. All right, let's get another brand new sketch and really put this into practice. So here's our directions. State the coordinates of a point on the unit circle whose angle is 30 degrees. So again, we've got to sketch ourselves a unit circle, and we're going to do this a lot. Okay, so now it specifically says 30 degrees. I have to figure out where 30 degrees falls. Well, remember, this is, let's get it on here, this is 0 degrees, and it goes up to 90 degrees. So I know 30 falls between there. If I drew it halfway, that would be 45, so I know it's a little less than halfway. So I've got my initial, and I've got my, let's say that's 30 degrees. Okay, now here's what I want you to do. Once you hit point P on the circle, I want you to drop straight down to make a right triangle. Okay, now I'm going to say point P for the time being is x comma y. But I really know what we just discovered is it's no longer going to be called x comma y. That point P is going to be called cosine theta, sine theta. Now, looking for an easy way to remember that, the order, basically just think alphabetical order. C comes before S. So cosine theta, sine theta. Okay, so now look how easy this is. I can really say, since that's an angle of 30, point P is really the cosine of 30, comma, the sine of 30. And why did I pick 30? Well, that's the angle in my triangle. Okay, so notice again, 30 is in the triangle. Now, lucky for you, these are numbers you have memorized. Okay, so picture that table, close your eyes, mentally picture the table, the 30, 60, 45 table. The cosine of 30 is radical 3 over 2, and the sine of 30 is 1/2. So now you've discovered the exact coordinates of point P. Radical 3 over 2, comma 1/2. Now, remember we said we knew they had to be between the numbers 0 and 1 because this point, recall, is 1, 0. Therefore, I know my x value has to be less than 1. And this y value is 0, 1, so I know that y value had to be less than 1 as well, and a half certainly is less than 1. All right, let's try another example. All right, find the coordinates of a point on the unit circle given an angle of 150 degrees. All right, so the key thing I want you to do, guys, is just underline that word unit circle. That's what gives this away. So I know that we're all 1 away from the origin. So let's go ahead and get our circle drawn. And then, of course, draw your axes in. Okay, so remember, unit circle means I'm 1 away. Now I need an angle of 150 degrees, so I'm going to label my degrees 0, 90, 180, 270, back to 360. And I know 150 falls between 90 and my 180. And I'm going to draw in my angle of 150. And I'm going to label that point P on there. Remember, I need an initial side and terminal side. Now, watch what I do. Mark that 150 in there. Now recall, you have to make a right triangle. At the moment, you don't even have a triangle. So you always want to drop point P straight to the x-axis and over, and that's what's going to make the right triangle. Now, we have to be smart. Is 150 even in your picture? No, it is not in the triangle. You have to figure out, you remember what we called that? The reference angle. How big is the actual angle in the triangle? Well, think, just common sense. If you know this whole thing's 180, and you know this angle is 150, your degrees of separation with the x-axis are just 30. Good job. Okay, so now I can easily label point P, and I start every time. I say, okay, point P is the point x comma y, but in trig we call that alphabetical cosine, and again, pick the angle in the problem, 30, sine of 30. Now, I went a little ahead of myself here. I missed one big deal. So let me go back here. Before I actually write this down, I'm just going to scratch it first. I'm going to say it's really the cosine of 150 and the sine of 150. But I noticed the 150 is not in my triangle. So here's why it's a big deal, guys, because we've got to watch our little saying, all students tip cows. And let's go ahead and get that written in there. All students tip cows. Because only in the second quadrant sine is positive, which makes cosine negative. So when I go to rewrite this, I apologize, I should have written negative cosine of 30, positive sine of 30. Okay, and did you catch why again? Sine is positive, so that's why this one stays positive, but cosine is negative. That's why I had to slap a negative on here. Now let me throw some common sense at you. If I told you to pick a point in this quadrant and you started at the origin, wouldn't you need a negative x value anyway and a positive y value? So hopefully common sense is telling you this number should be negative. Okay, now again, lucky for you, these are two numbers you had memorized. This is going to be negative, picture your table, close your eyes, the negative in cosine of 30, radical 3 over 2, comma, 1/2. And there you have it, point P on the unit circle. All right, so let's try one more similar one before we move on. Find a point on the unit circle whose angle is 240. So go ahead and get your unit circle sketched and get the angle of 240 drawn. All right, so remember this is 180, 270. I'm going to draw in my 240. Okay, so here's my angle of 240. Remember this whole thing is my 240 degrees. Here's my point P on the circle, and I'm going to go straight to the x-axis. So it doesn't matter what quadrant you're in, you're just always going to the x-axis. Remember, that's how you find a reference angle, the degrees of separation with the x-axis. Now remind yourself, 240 isn't really in my picture. Okay, but I'm going to start by saying point P, x comma y. Remember alphabetically, so I'm going to say it's the cosine of 240, comma the sine of 240. Okay, but I can't use 240 because that's not a number I've memorized. So I just have to say, okay, what is the reference angle in my triangle? Well, if that whole thing, again, a little common sense, is 240, and you know this line is 180, how far are you away from the x-axis? That reference angle is 60 degrees. So I'm going to say, all students tip cows. Again, common sense, the x value is negative and the y value. So I'm going to say this is equivalent to negative cosine of 60, comma, negative sine of 60. Make sure we catch that negative in both. All right, and again, we have these memorized, so this is just negative, close your eyes, picture the table, cosine of 60, 1/2, comma, negative sine of 60, radical 3/2. And again, there's that point on the unit circle. All right, have you got the feeling that tangent's been left out so far? We've talked a lot about sine and a lot about cosine. So let's just kind of recall. The x value in trigonometry is cosine. X comes before y, cosine comes before sine. The y value is called sine. Where does this tangent come in? So at the moment, I want you to box those two in, and I want you to box and star in this next important piece of information. And I just want you to take my word for it right now. We'll talk more about it in another video here. But tangent is equivalent to the sine divided by the cosine. Okay, so tangent theta equals sine theta divided by cosine theta. And like I said, at the moment, I just want you to take my word for it, and I'll show it to you how we're going to use it in another slide, and we'll prove it more in another video. But tangent equals sine over cosine. Well, you probably know what I'm going to say by now. Go ahead and get a unit circle drawn out. Okay, now the bigger you make this one, the better. So I'm going to say, let's say, theta equals 60 degrees. Okay, and I want you to draw an angle of 60 degrees. So here's my initial, let's see, I'm going to be over here. Here's my 60-degree angle. And I want you to hit that point P, and we're going to drop straight down to the x-axis to make our right angle. And at the moment, we can label one thing. We know the hypotenuse has a length of 1 because it's the unit circle, and unit implies 1 away. Okay, now I actually know this x distance, right? Because x is equivalent to cosine, and this is a 60-degree angle. I know the cosine of 60 is 1/2. And I actually know this y value because in trigonometry, y is equal to the sine of theta, and I know my theta is 60, so the sine of 60 is radical 3/2. Okay, so I actually know all the sides of this triangle. Now, I want to label some letters here, so let's go ahead and call this O for origin, and let's call this Q, and we have point P, correct? One thing you're going to have to be able to identify are the lengths of these sides. For example, in this picture, cosine theta, we just said has a length of 1/2, but that is from letter O to Q. And how do I know that? Well, again, the x value is the cosine value. You should also know the sine value, because sine, again, just represents the y value, so the y value to point P on the circle is P to Q. Okay, and we know this is the unit circle, so it has a length of 1. So this is my cosine, and this is my sine. Now, what we're going to do in this picture is we're actually going to extend line OP out a little further, and we're going to drop it kind of straight down, so it just touches the unit circle on the outside once. Okay. So can you see that there's two triangles here? I have this little triangle with a 60-degree angle, and then I have this bigger triangle with a 60-degree angle. Now, when a line touches the circle once, it's a word you're familiar with from geometry. When you skim the edge of the circle once, you are called tangent. So I want to be clear, right out here is the tangent line. Now I'm going to go ahead and give it some other letters. I'm going to call this M and N. So not only do I know sine, cosine, and cosine, I now know tangent of theta is equal to the line segment MN. And again, tangent just touches the circle outside of it once. Okay, now watch this trick. I asked you to take my word for it that tangent theta is equal to, and go ahead and jot this down, sine over cosine. Okay, now in this case, we're trying to show that tangent of 60, because that was my reference angle here, is equal to the sine value over the cosine value. Well, remember, the sine is the y value, so that's radical 3 over 2, divided by the cosine value, which is the x value, so divided by 1/2. So now I have a simple complex fraction, and if I multiply both the top and bottom by 2, that kills those, and I get radical 3 over 1. And what does that show you? That the tangent of 60, which again is something you should know from your table of values, is equal to radical 3. So anytime I take sine divided by cosine, I get tangent. So back in my picture, I now know that that length of mn that we labeled here as tangent actually has a height of radical 3. Once you've got this copied down in your notebook, turn it back on and we're going to talk through this. So go ahead and pause it and get it copied down. Okay, we should be able to identify which line segments are represented by cosine, sine, and tangent. Hopefully pretty easy. Okay, so the first thing I want you to do is just highlight the point on the unit circle. Okay, so this is the triangle I'm going to focus on, is the one on the unit circle. So remember, cosine, you're thinking of the x distance. Sine, you're thinking of the y distance. So as I look at this picture and I start the origin, I'm going to go over x and down y. So I would say the cosine distance is O to S. The sine distance is the y distance. So that looks like S to Q. And now remember, tangent is outside of the circle. It skims and touches the circle once. Which line segment do you think touches it once? I'm going to call that a P. So I'm going to say this line here just skims and touches the circle once. So my tangent is P to R. So you notice it doesn't matter what quadrant you draw it in, it's all the same. When you see cosine, think X, sine, think Y, tangent is outside the circle. Now, I'm going to throw one more at you from your geometry days. You did talk about secant lines, and a secant goes through 2 points. So if I look closely, I would say P to O here goes through the circle. And it could extend, so I would call that my secant line, P to O. All right, determine the ordered pair on the unit circle. Theta equals 3 pi over 4. Now, you might be scared because it's in radians, but it's really no big deal. Put it in degrees for yourself. So hopefully you're saying that's simple enough. I just multiply by 180 over pi. Or I'm hoping by now some of you that are a little quicker with the trig values can pick up that you already know pi over 4 is 45 degrees, and you're just multiplying that by 3. So 15, that's a 135. So go ahead and sketch your unit circle. If that went way too fast, just multiply by 180 over pi. I've got my unit circle. Get your line drawn in, your axes, and I want to sketch 135. So an angle of 135 would look like this. Okay, now remember, you got to make a triangle, drop it to the x-axis. Nice right angle. Now 135, I'm going to get set up here, so I know that this point P is x comma y, and it goes cosine first, so it's the cosine of 135 comma the sine of 135. Okay, now I've got to talk. All students, every time I have to say that, tip cows, all students tip cows. So I know that my cosine value is negative, and my sine value is positive. All I need to get is that reference angle. I can't use 135, that's not a positive acute angle, but I can say, okay, let's see, this whole thing's 180, that's 135, quick subtraction gets me 45. So negative cosine of 45 comma sine 45. And again, you're pretty lucky, that's a value you have memorized from your table. Close your eyes and picture that 45 column. I would say that's negative radical 2 over 2 comma positive radical 2 over 2. Now, if they wanted tangent real quick, well, we know, remember our little rule, is tangent equals sine over cosine. So look how nice this is. Radical 2 over 2 divided by negative radical 2 over 2, well, that's the same thing divided by itself. That just equals negative 1. In our next example, we're given the coordinates and have to determine the angle in degrees. So here's what I'm thinking. I'm going to first get that unit circle drawn. And I'll draw my axes in. Oops. Okay, Now let's just use some common sense. Start at the origin, and you're going to go negative 1/2. So here's the origin, negative 1/2, negative radical 3 over 2. So that puts point P down in the third quadrant. Okay, so I'm going to draw my angle out. Remember, the theta is actually this whole angle, but we're going to drop our triangle to the x-axis. Okay, now it's very simple at this point. We just say the x value is cosine theta is equal to negative 1/2, and the sine theta is equal to negative radical 3 over 2. So now just work backwards. Picture that table in your head. Close your eyes and picture that table. When does cosine have an answer of 1/2, and at the same time, sine has an answer of radical 3 over 2? Hopefully your gut's saying 60 degrees. So that's not the answer to the question. Remember, this just represents the reference angle. That's the angle in my triangle. I'm going to highlight it green. 60 degrees is the reference angle. Now it should make sense that that can't be the final answer because 60 doesn't even fall in quadrant 3. So how do I get an answer in quadrant 3? Well, I'm first going to take this 180 that I just made, and I'm going to add that to my reference angle of 60 degrees. So my final answer is going to be 240 degrees. And that should make sense because that's an answer, of course, that falls between 180 and 270. And I just said it's this half circle, 180, plus the reference angle of 60 I found. Now, believe it or not, guys, there's a ton of other points on the unit circle. We just happened to pick ones that we knew the reference angle to, the 30, 60, 45. But I'm going to give you an example where it's one we don't know. So it says find all possibilities for the coordinates given an x value. So let's say x equals 3/5. So recall the unit circle means 1 away, so that's x squared plus y squared equals 1 for the unit circle. Well, if they tell me an x value, I can simply plug it in. 3/5 squared plus y squared equals 1. I'm going to keep going. That's 9/25 plus y squared equals 1. I'm going to subtract that 9/25 over. Now I don't have a calculator, so again I'm going to show you what I do without a calculator. 1 minus 9/25, I just write this as 25 over 25, that's equivalent to 1, minus 9/25. So that's equal to 16/25. So I've got y squared equals 16/25. If I take the square root, I actually get two values. I get plus and minus. Square root of 16 is 4, and the square root of 25 is 5. Does it make sense that I got 2 points? So let me recall what my point is. My x value was 3/5. I got a positive 4/5, or I got a negative 4/5. So does that make sense that I got 2 values? Well, I think so. Picture that unit circle. If I go a x value of 3/5, I could get a positive 4/5 or a negative 4/5 for an answer, correct? So it does make sense that if my x value is positive, I could get a positive y value or a negative y value. So you'll notice I have 2 points here. Well, we look forward to seeing you tomorrow and getting some great practice in class. Have a great one.